Okay, so with this question here, we've got a truck which is moving on a straight line on a horizontal road, okay, and this force is acting on it, and we're asked to find the acceleration. So you need to draw a sketch, right? Sketch is what's needed here to dissect this question. Now, there's my truck, right, on the road, yeah, and it says that it's got a mass of 5,500 kilograms, so that means its weight will be 5,500 g, yeah, because you times the mass by g for 9.8. Of course, there's going to be a reaction then which acts perpendicular to the surface, okay, and it says then a driving force of magnitude 10,000 newtons. Now this term driving force is essentially the forward force produced by the engine, okay. So the engine is working hard, isn't it? And it's producing this forward force, pushing it forwards. But there is a resistance. There's a resistive force, which means, essentially, it's pulling you back, yeah? Resistive force means something holding you back. Now, that could be anything. It could be the friction between the car, between the tyres and the road. It could be air resistance, okay? It's going quite fast. Maybe there's a lot of air there you're sort of working against. That magnitude is 1200, the resistance there, okay, and that's it. There's no other horizontal forces. So you've got the forward force here and then the resistant force. Now when you look at this, it's quite clearly this truck is going to be accelerating this way, okay, right, because the resistant force, even though it's quite large, well, the driving force is much larger, isn't it? So this truck is moving, right? So what we can do then is appreciate it's accelerating that way, and if we then use Newton's second law, okay, in the direction of motion, okay, so in direction of motion, well, remember Newton's second law, quite simply, is the resultant force equals to mass times acceleration, okay, so F equals ma, okay, as we have learnt. So the resultant force, well, the overall effect is the resultant force, isn't it? So it's not just going to be 10,000, okay, because that is the driving force. But remember now there's a resistance force, okay, pulling back at it, so we're going to take that away from it, okay. So the overall effect will be less than 10,000. That equals to mass, which is 5,500, times the acceleration. So I work this out on my calculator, I get 8,800, okay. That will be the resultant force, equals to this. To get A then, you've got to do 8,800 divided by 5,500. So the acceleration will be, I do that on my calculator, 1.6 meters per second squared.